Alright, draft science video. So yeah, I found some more Pyrrho comments on gravity waves and what used to be Carla Della Stella. Just ignore hers because hers are vacuous in terms of any information, but just you're not allowed to insult scientists or something. And somehow everybody else doesn't understand and tell me they can understand their subject or something. Which is just nonsense. So I guess I'll begin with Pyrrho's first comment, and then I'll just point out how obviously he doesn't pay any attention to current events at all. He doesn't. Again, lack of detail. And it just annihilates the subject because this is kind of important details. So anyway, the existence of gravity waves is not odd. It's what one would expect. Yeah, now that's in the common sense. So let's go back to Einstein in whatever 1916, and the obvious point is they had just started doing this whole radio wave thing, and understanding frequencies being created by oscillating machinery. Lots of things created vibrations. Those vibrations would create what were called waves. Now the waves are basically just a pile of photons in the case of radio, and but they didn't have they didn't have the same context we have to make that all quite obvious, but they were sort of getting the idea that light wasn't the only kind of photon, and there was a whole range of these photons, and that's what radio was and all these other things. But it wasn't quite as clear as it is now in 1916, of course. But the idea is that, well, yeah, we have these. If we have things in the universe that are doing this oscillating thing, and the oscillating thing would basically just be, you have two things, and one of them is circulating the other. So let's say the bigger one is circulating the smaller one, or so some comparable size difference. The point would be is as if one of them was on fire. Okay, then the light would keep getting blinked out. So if this one was on fire, then it would be blinked every time this way, and if this was on fire, then it would be on all the time. It would blink before when it goes behind this one. So the idea would be that the light would blink, and then would create a signal, and that was the pulsar. And so yeah, the theme would be is that gravity might do the same thing. And that gravity, their idea of gravity is that everything's bending this space, so there would be double the space wave bend coming off of these objects. If you were facing the two objects and they were in line, there would be a double thick wave created. And then when they were at opposite ends, if they were going across from each other, if they were cycling each other, it would be only a little two half waves, right? So the point would be is that you would have a strengthening and a weakening of the gravitation. So even though this would be a negative bend in space, there would be points where there would be double bend and then half a bend, and then double bend and then half a bend. And you could understand that as being a frequency, and that theoretically we could detect that. So that's kind of what Einstein thought. But then later on, when he did the math, he kind of figured that you'd have to have incredibly massive bodies to do this, and then that was starting to create this singularity problem, where you're just making an endless amount of gravity and all that kind of stuff, and that gets kind of dangerous. And so he wasn't too sure that we'd ever be able to detect them because you'd never have a source strong enough. Okay, because the point is, like the light, it's this inverse square thing. Now, even though Einstein, I think, knew that gravity must be stronger than these positive forces, like the photons coming off the sun, clearly is a much weaker force than the gravity, the pulling force in. It's quite obviously. So you would argue that gravity, as it moves through space like photons, the same speed, that it would be a bigger noise if we could build an instrument to detect it. It's more than the photons. So we know it's only a tiny amount of photons that we can see from something very, very far away, right? It's like, you know, I mean, if you take all the photons coming from a star to the Earth, it's a tiny amount, a light bulb or less amount of energy that hits the whole surface of the Earth. But the gravity, if it had a wave to it, if it had a frequency because two things were moving, that wave would be a little stronger than just regular photons. So it might be able to reach us in some form that might be detectable. So that was sort of the debate. Now this new gravity wave theory that they've detected, the signal is so loud, because they can only really detect kind of loud signals, that there's no way to make an explanation. The thing would have to be really, really close to make a signal that loud if it was just regular gravity. So they have to come up with some way to make this signal more energetic, because it's just too loud. So they have to make it into this black hole scenario where 3 solar masses are annihilated and turned into bent space. There's no way they can make it make any sense, apparently. But it's not really what Einstein was talking about. Einstein wasn't talking about annihilating solar masses and converting them into space-time. Technically a positive force. This gravity is an absence. And clearly by my understanding, gravity only is, first off, it's inductive, which means if they ever go, they kind of got a hint of this, I think, already. Because I think one of the little satellites that took pictures of Saturn or whatever, it did go up out of the solar system. So it didn't leave the solar system in line with the planets. It left going out. And I think they found out that there's less gravity out there, because the gravity is induced. And so it's like, you know, I'll argue that a galaxy facing this way and a galaxy facing this way, all the gravity is on this line. There's no gravity on this plane. Barely any. And there's certainly none if you're not a heavy body coming towards it. Gravity is entirely induced. The Earth induces gravity in the Sun induces gravity in the Earth. They don't have it innately. You have to have it through your relationship with the thing. The gravity doesn't exist until you make it happen, because it's all about the acceleration. Your acceleration is your deny. That's when you deny the other body gravity, and that's when you're pushed by the extra force. So, you know, that's another reason why this gravity wave thing is a little dicey. Okay, so with that context, so Pyrrho's doing this preaching thing that it would be a wave, it would be odd if we did. No, there's nothing odd about it. The point is, it'd be odd to be able to detect them, and that's really the argument. Because of the inverse square law, the gravity, as you get any kind of distance at all, gets so incredibly weak. Okay. To not have them would require the gravitational pull to be instantaneous. Well, that's another. Nobody's making that argument that I know of, that there's anything to do with this instantaneous thing. People have known gravity moves at the speed of light for a very long time. Going back to almost Newton's time. Because it's kind of how they, you know, it's how, well, I won't get into. Anyway, let's continue. If a giant spaceship moved the sun, would its movement in a new location be felt immediately? If a giant spaceship moved the sun, would its movement to a new location be felt immediately? Is it instant? Like I said, who's making that argument? So he's, you know, this is completely a straw man argument. No, I don't know of anybody who's making the argument that the reason why gravitational waves couldn't exist is because gravity is instantaneous. Who's making that argument? Is it instant? No. Would it make sense for it to take no time for, he just keeps making this argument, for that new, you know, he puts it in capital letters, for that new pull from the new direction to be felt? Whose argument is that? Einstein in physics, since his found, since has found the math for instantaneous things does not exist, can't work. Well, again, whether they can make math for it to work or not, it seems quite obvious that it would be paradoxical and it would break conservation rules, and it would also create a circumstance of instantaneous communication, because clearly then you could use gravity to communicate. You could figure out how to, let's say, do as I just proposed, maximize gravity, alignment of planets or some other things, so you could navigate satellites in certain ways and perhaps be able to send signals instantaneously. Time is part of everything that happens. That's irrelevant, which really makes sense since time just is things happening, which is just babble. I mean, it sort of just is babble, because quite obviously things happen, they metabolize or process at different rates under different circumstances. Light moves slower. It processes through some materials quicker than it does other materials. Clearly the light's still moving the same speed, it just takes more time to get through the material. And has come to the conclusion that nothing can go faster than c. Again, this is not the argument. And light is one of the things that goes close to the limit as possible. So she posted a statement about some Chinese physicist who is kind of skeptical about the whole bent space thing. And I don't even know if that's directly related to this story, because again, it doesn't dispose of the concept of gravity or its migration through space, but it's certainly relevant to what you're detecting, whether you're detecting a positive force or a negative force, a pull or a push. But there's just nothing in here about any instantaneous thing. So he's made a whole argument as if somebody's making an argument about instantaneous gravity, and nobody's making that argument. If gravity takes any time at any speed, however, it will see ripples in gravity whenever a body is itself under acceleration. It would have to be acceleration in the direction, though, of the gravity. So, technically that doesn't even make sense. If I accelerate, and I'm absorbing force from behind me, so I'm absorbed a bunch of force, you could argue that could make sense in the direction I'm moving, but why would that give me gravity going sideways or gravity behind me? Yeah, not so. Such as a collision in orbit, due to the lag of the effect being seen far away in combination with the fact that the body is under acceleration. Again, I don't see how those are obviously connected at all. The point is, gravity is rather conservative in terms of when stuff goes into it. It has to, the same speed you get from gravity you give back when you escape gravity, and that sort of makes it conservative. But the idea that it's always been sort of a problem with this bent space thing, if you sit there and not recognize some kind of limit to the fabric. So if it bends all the way, a billion light years away, well, yeah, I mean, obviously that's what it does in the real world. I mean, that's just a fact that there's no theoretical end. It goes to affinity in some form, but that form again gets so small. But we already know that we see light from 15 billion light years away, so it does make it here. It's just very weak in terms of the amount of it. And again, that's the argument, is the amount, which Pyrrho isn't recognizing. But the argument is they converted 3 solar masses into gravity, and there's no explanation for how that's accomplished. Deeper issues relate to if the force of gravity will be quantized and transmitted by some wave particle, as with other forces. Some wave particle. So again, what does that mush mean? Wave particle. It either is or is not. I mean, it seems pretty reliable when it's a photon. How come these other particles Again, the photons are pretty reliable. So there's no question about what's waving. It's not the photons that are waving when they're coming from a neutron star. We clearly see the source of the wave. There's no confusion. It's not about the photon waving. It's about the production of the photon coming in waves. Waves of photons come, not waving photons. So now he's turned gravity into a wave particle, when no, it's coming in waves of particles. Just like radio, waves of particles. So again, that's just a, it's a mischaracterization of the reality. Again, I mean, inaccuracy. I mean, it's just too fucking sloppy. Is it possible this, when checked, will not be It's possible this, when checked, will not be gravity waves. That's a weird concession. But that's not what I was talking about. I'm saying, why wouldn't there be ripples in the way gravity arrives sometimes? And again, no one's arguing there wasn't. The argument is whether they could ever be strong enough to be detectable, in the sense that gravity, weak gravity, is really hard to detect. Correct? Yes. I'm asking if you think instantaneous action at a distance makes sense. Again, I don't know why does she have to account for instantaneous action? She's not arguing no one's arguing instantaneous action. So again, it's just a false, he completely misunderstands the argument being made. I think things affect each other I think things affecting each other is time. Another one of his great sentence. That's what time is most fundamentally. Time is affecting each other. So photons go across the entire universe, not affecting a damn thing. And somehow they're still stuck in a time equation. Whatever else we find out about it. If imagined frozen in an instant, nothing is interacting. So instants are not points. They are tiny time intervals. And thus there is time in all moments. La 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 la. And all things take time, which means happen over time. Yes. I mean, it's quantizable, quite obviously. I think, quite obviously. But I'm just saying that was already a known as soon as you understood there was a limit. Possibly those exchanges cause time, but in any case it seems by definition a term involved in whatever turns out to be the case. I just don't understand. Where was anybody arguing that gravity doesn't obey the inverse square law? So who is he arguing with? And then time doesn't exist. It isn't a conclusion that could happen. And then time didn't exist. Okay, so he's quoting somebody. I didn't see any quoting where she was saying that. What is time? And in the case we find out what we thought it was before. It's an illusion. But time is really just the name of things interacting. Well, it's just silly to say it's the name of things interacting. You mean things interacting that takes time, that doesn't happen, everything doesn't happen instantaneously. So, I mean, it's just silly. I mean, it just seems quite obvious that stuff takes time. And it's not an illusion, it's just quite obvious that it doesn't happen instantaneously. Those are your only two choices. Forever, time, or instantaneous. It obviously is not taking forever. Anyway, let's see what it says. This is a Carla one. I'm a science elitist. Sorry. Yes, science should be questioned, but only by other scientists who know exactly what they are talking about. So lawyers should only be questioned by other lawyers, and politicians should only be questioned by other politicians. I mean, this standard is idiotic. And everyone else should shut up. Well, that's just too stupid. So yeah, enough of that already. We should trust the Pope. Well, it is. She was a religious nut, so. Pyrrho. Well, yes, that's a lot like Einstein's idea about curvature. So she said here, you might be interested to know that Professor blah, blah, doesn't exactly deny gravity, but he said he thinks that it is a byproduct of a kink in space-time continuum. Well, whatever that is. Who cares? Rather, according to his argument, it is caused by quantum or subatomic particles that lack mass. It's photons, stupid. I mean, goddamn, it's obviously just a little bit off. Close, but no cigar. Let's see. Well, yes, that's a lot like Einstein's idea about curvature. No, Einstein's idea about curvature has nothing to do with photons. It's clearly a pull force. It's clearly not accounted for as a force at all. The energy to do all of it is all in a separate dimension that doesn't have anything to do with any common reality. I mean, it's just idiotic to say Einstein has something to do with particle physics. Space-time has nothing to do with particle physics. It's like longitude. Things going parallel north will converge at the pole because of the curvature of the planet. Oh, this is so stupid. On a spherical curved surface, a straight line is a circle. In fake dimensions that don't exist in reality. Yes, if I squish a circle, it's now flat. I mean, you can't do that in reality, though. The flat universe is not curved. There's just a relationship that has to do with curves. There's 3 dimensions. The 3 dimensions basically define 6 segments of a circle. There's lots of ways you can look at it, but I mean, and obviously pi, the whole idea of circle is very fundamental to the math of the universe. But to argue that because there's a relationship consistent with that idea, in like even the inverse square law, is basically the idea of how area changes with changes in radiuses, that it doesn't happen by like that, the area changes by a cube, the circumference changes by a square. These are the sort of the rules, and because there's an incidental relationship, he assumes, as Pyrrho always does, that means there's a qualitative relationship, and it's just an incidental relationship. Anyway, this is how the idea that space is warped by mass energy can be used to explain gravity. No, it just explains the fact that you can create the inverse square parabola by creating curved space, but it has nothing to do. The two things don't have anything to do with each other. The inverse square is the exact same law that's created by the shadow of my hand. By moving my hand towards the camera, I'm doing exactly the same curve of curved bent space-time. This is exactly the same thing. And it should be apparent to anyone that my moving my hand has nothing to do with space-time being warped or bent, or anything being warped or bent. And that really just has to do with force law. The force of my hand at half the distance is 4 times as big. That's just a fact of how the universe functions. And the force of gravity would be the same as the photons that make up this relationship. How else to say that? But that's what all gravity is. It's photons, and it's obeying the same rules as photons. Oh, shit. Gravity waves are part of the propagation of spectral deformation. There is still a point in the deformation, whatever that means, or any other explanation, propagating over time. Whatever the cause, well, now he just turns the cause into whatever the cause. If there is time involved in the propagation, then you would expect that what we call gravity waves. Again, you would expect them even if they move 5 times the speed of light. I mean, it doesn't. Who cares about what speed they're moving at? The fact that gravity exists. I mean, again, there's no logic. You can't really logically have an instantaneous force, so that's sort of a moot point, isn't it? I mean, he keeps arguing like it's not, but whatever. So, let's see. Pyrrho on the South China Morning Post headline, the article, Einstein was wrong. Yeah, well. Question your general skepticism. So anyway, so I'll read this one just because Vic says here to that one, I assume, even though he didn't post it correctly. I didn't question you. I questioned the general skepticism by lay people in regards to recent findings on gravitational waves by LIGO. People don't have respect for any authorities anymore. Well, again, just because authorities have been quite disrespectable. I don't think it's healthy when the plebes has no respect for anything anymore. It's a sign of egomania and lack of humility. Well, I would almost argue that the experts who are the ones lacking any humility. It's another symptom of the degeneracy of society when people don't have trust in any authority whatsoever. Well, I don't think it's gone that far, but clearly when, you know, cops are opening doors with a gun in their hand and doing other stupid things, you know, you do have to question their competence and think anyone lies and everything is the New World Order conspiracy. Well, again, you're just another false straw man argument. The argument isn't every authority is an asshole. The argument is if they're going to say something happened, they ought to be able to demonstrate it with something called evidence. They shouldn't just say, trust me. Right? Right. So, and he says, here to that crap. You know, because Vic thinks we all should trust Obama. You know, whatever. So, it's all quite disgusting. So anyway, that's the end of Pyrrho's commentary, I think. Alright, so anyway, these people are just so... So anyway, the point is that the important feature of this, in my opinion, the big one, is the fact that they say 3 solar masses were annihilated in this process, and that is somehow accounting for the strength of this wave. And the only way that, and like I said, the annihilation is just how does that happen? How do you take something where you're supposed to be bending space-time with mass, and now you've destroyed the mass, turned it into what are traditionally photons? They're not photons that you can see. You know, but see, they're not saying go look because there's 3 solar masses, you know, just blinked, and you should be able to see it. But it blinks so fast that you wouldn't even see it, right? That's the trick of this thing, right? So even if it was photons, it would somehow blink so fast that 3 solar masses would create these huge waves of energy. See, they can't say that happened because it would be irradiating everything on the way. I mean, if you annihilate 3 suns in 0.2 seconds and convert it into, release all of its energy as photons, I think that would be bad news for an awful lot of the universe. Would be highly irradiated by that process. Yeah, well, you know, who knows. So anyway, that's the question. The question is, are they claiming a dent in time, space-time? Are they claiming a bulge in space-time? What thing hit the Earth? And how is it possible that it was created 1 billion light years away without us having the expectation that a big portion of the universe would have been evacuated by the force of such an event as it would necessitate, in my opinion? And we're not allowed to ask those questions, though, because we're not professionals. Okay. Well, anyway, yeah, I'm just not even going to dignify that this idiotic notion that these subjects are beyond people's competence, especially when all the lectures are online. I mean, they're online. You can watch them. So, fuck you, bitch. And, yeah, once again, Pyrrho was not anywhere close to the subject. The subject is the 3 solar masses converted into some kind of space-time event. Basically the destruction of matter and its conversion into space-time. Essentially. No other reasonable explanation. If it's not photons, what is it? And if there's a what is it, if there's a answer like gravitons, then why aren't the gravitons pushing the Earth into the sun? Okay, no. Till next time and such.